It is accepted that cognition is distributed across parts of the brain, and that various memories and experiences can be integrated with our environments or purely exist within our heads. Most frequently, cognition exists in the rich human environment where we interact with one another, use tools, rely on our experiences, and rely on the past experiences and knowledge of others. Researchers are now exploring the boundaries of these types of cognitive processes to include person-to-tool, person-to-person, and teams using tools, and considering all of these situations generally like an extended mind. These situations are the reality of our everyday lives. They're the way humans have always worked. I would like you to look at these pictures for a minute and consider the coordination and collaboration and the numerous tools and systems that are required to sail a ship in real-world conditions of wind, rain, and tide, not to mention the incredible diversity of human factors that impact our performance. The movement of a ship are the collective sum of all the interactions of its crew. It is beyond the capability of any one person to perform such a complex task. It requires individuals to know and perform their jobs. Most of these jobs are performed with the use of tools, what researchers call artifact-mediated activity. Individuals make sense of the data coming from their tools and recognize the patterns coming from them. In many cases, individuals also rely on job aids or more experienced people as they mature their knowledge. This assistance, or scaffolding, gradually fades away as individuals get really good at their jobs. A ship also requires collaborative action that is distributed amongst a community of people. We do have to eat and sleep after all, and none of us is as smart as all of us. The collaboration manifests itself in a community jargon, rapid teamwork, implicit communications, identification and correction of small errors prior to system failure. It is clear when teams trust each other. It is also easy to see poor performance of dysfunctional teams. When a ship pulls together its individuals and teams and aggregates their knowledge, they can function both during calm, favorable conditions and in dangerous, uncertain ones. It was helpful for me to consider distributed cognition as the extended mind. Hello everybody, this is Sean Reardon from Dr. Ruckard's EAC585 from North Carolina State University. Happy to present this quick brief on the distributed cognition theory. Distributed cognition, or DCOG, is a highly practical theory that can help in redesigning instructional systems by putting the focus on the individual learner and his or her work environment. When thinking about distributed cognition theory, it is helpful to keep the interplay of individuals, artifacts, meaning prior knowledge perhaps, tools, consider any number of computing, technological, or measurement devices, and the environment, which can range from things like the physical environment to the IT environment of networks and clouds. To the distributed cognitive theorist, learning is an adaptive reorganization in a functional system. This means that both individuals and organizations learn, change, and adapt as a result of these interactions. The change is the evidence of the learning. I hope the upcoming example will help you to understand this important point better. I found the example of the navigation of a ship to be very helpful in understanding the theory of distributed cognition. This example is derived from the work of Dr. Edwin Hutchins of the University of California at San Diego. In this example, a team using specialized tools and coordinated action was able to do more than any individual participant. If you look around the simple graphic here, you'll notice the various sailors in the Dixie hats and striped shirts. These sailors each have a job that employs various tools. The sailor in the top mast with the telescope is observing for obstacles and landmarks. He is making sense of those images and communicating them to the watch officer who is assisting the ship's captain, neither of whom can see what the man aloft can see. Then there are 4 other sailors around the graphic depicted using a gyro compass, a slide rule, a sounding device, and a sextant. Each of these sailors is offloading a part of his job to the tool. He can do more, faster, and with less errors relying on this tool than he could if he had to do these calculations solely in his head. You'll notice the sailor in the front with the sextant has an anchor next to him. This anchor represents a senior sailor who has grown up sailing and using the various tools. His job is to watch over the younger sailors, provide them guidance, and his presence amplifies the junior sailor's natural cognitive abilities. All of these jobs must be done in an ever-changing weather environment where sea conditions can quickly change, causing all of the sailors to modify their internal perception or cognition and communicate it throughout the system so that others likewise can modify their own internal cognition. Pictured below the ship is a nautical chart of Cape Lookout, North Carolina. This artifact represents the collective trial and error, effort, countless voyages, and experience of sailors past. I find it helpful to think of the charts as the storage of past cognition. This ship and the individuals using the map all make use of the chart to interpret the knowledge and communications coming in from the various sailors who are calculating speed, depth, directions, etc. Likewise, the captain and the ship's log are depicted on the deck of the ship. The experience and mature knowledge of the captain are products of the distributed cognition, because in the years it took the captain to go from midshipman to become the captain, he was exposed to the countless logbook entries and experiences. The captain does not have to share all of his individual experience with everyone in the system, even though it is he who is establishing the common understanding from all of the inputs. The captain may be thought as a sole decision maker, but in reality, he is co-creating solutions with his sailors. These solutions are decisions and orders which have been mediated by the devices, artifacts, and technologies from across the ship. The combination of all these individuals and tools forms a cognitive functional system for solving a particular problem. In this case, navigating a ship through restricted waters to go surfing at Cape Lookout. So, how could distributed cognitive theory be used in various training environments? Excellent question, Dr. Rucker, and I'll do my best to answer that question. Because distributed cognition is ostensibly about real-world situations, I'm going to attempt to show a modernized version of the sailing ship example and how learning still relies on the three levels of individual learning, collaborative learning within a community, and the collective mission level that would be impossible as an individual effort. The environment will shift from wind and rain to data centers and IT networks. Communications are no longer just voice, but they're electronic, synchronous and asynchronous collaboration tools, and tools are advanced computing solutions. The system still has scaffolding, but instead of a tough old sea salt of a petty officer, they're project managers, scrum coaches, and the like. So instead of sailing a ship, our mission is now to lead a multinational, multicultural team that is decoding the DNA of an extraterrestrial being whose spaceship has crashed into Earth. You'll notice that there's no central captain in this distributed cognition model. One could exist, but it is not necessarily or even efficient for learning. The problem set is one that has never been seen before, but all the previous research from other disciplines is considered vital. The central artifact of the process is represented by the data center at the bottom of the graphic. Researchers can learn from other parts of the project team as well as from the combined knowledge of previously completed and even incomplete research that is accessible through the IT environment. The IT environment is represented by the cloud at the top. This is the enabler of communication and collaboration and represents a knowledge in and of itself. Individual scientists and researchers working around the world utilize their own specific tools to accomplish various tasks. The person-centered learning results are archived and shared via the IT network that enables the individual discoveries in Osaka to near instantly inform and shift the perceptions of the researchers in Washington and New Delhi. The social interaction that occurs by sharing information amongst the teams helps on several levels to improve knowledge. First, errors that might not be caught by one team may be caught by others. Second, this project could take several years to complete, and there's an ongoing need to develop and improve the training systems necessary to prepare the next generation of researchers with up-to-date information and best practices. As much as possible, for efficiency's sake, the whole group are working in parallel, so as long as their work does not violate necessary sequences or critical path dependencies, distributed cognition is an effective theoretical basis to understand and appreciate how and where cognition actually exists, both in individual representations as well as the knowledge and structure of the environment. Dr. Edwin Hutchins is considered an early pioneer of the distributed cognition theory. His work, Cognition in the Wild, has been cited more than 13,000 times, according to Google Scholar. The field borrows from sociology, cognitive science, cultural history, and anthropology. Knowledge is actually attributed to the system, not only to individuals, which is key in understanding this theory. And it's been, the distributed cognition theory has been applied widely in designing distance learning solutions and computer-supported collaborative learning.